Hello friends, welcome to Basic Electrical YouTube channel. So in this video content, I am going to explain numericals of Module 2. Okay, that is VTU model question paper of Basic Electrical Engineering subject. University website has uploaded 2 model question papers for Basic Electrical Engineering subject. So in those 2 papers, numericals are there. So each module wise, I am going to providing solutions for numericals. In previous video, I explained module 1. Okay, it is having around 4 problems from both sets of paper. Totally 4 problems asked in module 1. All the problems are already done. In this video, in the same manner, I am going for module 2. Let's start with the first question. Okay, this question asked in set 1 for 6 marks. So let me read the question and understand. A circuit consisting of resistive of 20 ohm. So 20 ohm resistance and inductance of 0.05 Henry. Inductance values 0.05 Henry are connected in series. So R and L are connected in series. Across this circuit, across these elements connected in series, 230 volt is applied. A supply of 230 volt at 50 Hz is applied across the circuit. Determine, first question, current. You have to calculate what is current flowing in the circuit and what is power factor. What is the power factor and also what is power consumed by the circuit. See, whenever you are solving problems on AC circuit, whether single phase or 3-phase circuit, you must know how to find impedance. This is the first step. If you done this step mistake, almost entire problem will become wrong. So find impedance in a correct manner. So for a series RL circuit, impedance is written as R plus J XL. Whenever inductor is there, you must write plus JL. Plus J you must write. And instead of writing L, you must write inductive reactance, because unit of impedance is ohm, unit of resistance is ohm, unit of inductive reactance should be it is in ohm. So if you write L means, then unit of inductance is Henry. So different units cannot be comes under that impedance equation. So this is the standard. So whenever inductor is there, you write plus J. That's it. Okay. Now R value is given. I want XL value. So how to find XL value? XL formula is 2 pi F into L. So enter all the values. 2 pi into 50 into what is the value of inductance given? 0.05. So if I multiply this, please do along with me. So 2 pi into 50 into 0.05. So getting around, how much you got? 15.707. Okay, I too got same answer, 15.707 ohms. This is inductive reactance. Now enter both the values. So I am writing here, Z is equal to, what is the value of R? 20 ohm. Plus J, what is the value of XL? 15.707. So this is the impedance of the series RL circuit for the given data. See, you must keep the impedance in polar form. Okay. So if you keep the impedance in polar form, you can easily find remaining quotients. Okay. You can easily find power factor, power consumed, all other parameters can be easily found out, even current also. So convert to this rectangular form into polar form. So how to convert rectangular to polar? If you don't know means, need not to worry. In this video description, I am going to provide. I have done a video how to convert polar to rectangle, rectangle to polar in different calculators. You can go through that. I will send the link. Okay. Sorry, I will put the link in the description. Okay, guys. Now convert. While converting, you keep your calculator in complex mode. So let me do 20 plus 15.707 J. So converting into polar form. So getting an answer. Okay, 25.43 at an angle of 38.144. 38.144 degree ohms. Okay. So this is the impedance value. Okay, 1 minute. Okay, yes, I got same answer. I thought I kept in radian mode. You keep the calculator in complex mode and degree mode. Then you will get this value. See, in this 25.43 is magnitude of the impedance and 38.14 is angle. Okay, angle of the impedance. So now let me find current. So what is the equation for current? According to Ohm's law, E is equal to V by R. So in AC circuit, R will not come, impedance will be there. Okay, in AC circuit, current formula is I is equal to V by Z. See, you must write here, whenever division is there, you always represent it in polar form. So 230 volts. Angle is not given. So you take 230 at an angle of 0 degree. And what is the impedance? 25.43 at an angle of 38.144. Okay, calculate. Do this in a calculator. See, in AC circuit, calculator will take care. Okay, you have to write correct equation, rest calci will do. So let me do 230 at an angle of 0 degree divided by 25.43 at an angle of 38.144. So I am getting around, I am keeping again this answer in polar form. Always keep it in polar form. Okay. So 9.044 at an angle of 38.144 degree ampere. So answer for first question. What is the current in the circuit is this much current. This is the magnitude of the current and this is the angle of the current. Means minus indicate with respect to voltage, the current flowing in the circuit lags by this much angle, 38.144 degree. Okay. Otherwise, in a series RLC circuit, if the reference is voltage, current always lags. Okay. Current angle you should get negative for a series RL circuit. Next, what is the next question? Power factor. See, power factor formula, you can take this one, simple one, cos pi. Okay. So, cos pi indicates angle between voltage and current. So, what is that angle? That angle is 38.144. Otherwise, you can take impedance angle. Okay. You take only the value of angle. 38.144. Okay. That gives cos 38.144. So, we are getting a value 0.786. So, power factor of this circuit is 0.786. Lagging or leading? See, current lags the voltage by this much angle. So, you must write this power factor with this word, lagging. Power factor of this circuit is 0.786, lagging. So, another way you can also find power factor formula is, cos pi formula is R by Z. See, whenever you use this equation, okay, you take the value of impedance, magnitude part only. Don't take angle. What is the value of resistance? 20. What is the value of impedance? 25.43. You will get same answer. 0.786 lagging. Okay, second question also finished. Next is power consumed by the circuit. See, power consumed by the circuit formula is, so power is equal to, okay, red is not working, VI cos pi. Okay. See here, V, you write only the magnitude part. Okay. V and I both are RMS value. See, this magnitude indicates RMS value. This is RMS value of current. Okay. So, V is 230 and what is the value of current? 9.044 into cos pi. So, cos pi value, you already know that value, 0.786. You can write that itself. Otherwise, cos, what is the value of angle pi? 38.14. Okay. If you do it in calculator, you will get an answer. But don't take cos 0.786. That is wrong. Okay. Cos pi value itself 0.786. You take the value directly. Okay, got it? So, but I not taken like that. Cos, I put the value of pi. See, this pi indicates angle between voltage and current. Okay. So, calculate and tell the answer. 230 into 9.044 into cos 38.144. That is getting around 1634.97 watts. So 1634.974 watts. See, if your answer is more than 1000, you can represent it in kilowatts, no issue. Otherwise, keep it in watts only. So this is the power consumed by the circuit. Same question, if they ask in exams, they can make some changes. Power consumed, instead of calculate power consumption, find active power or find true power, find real power, find useful power, find average power. For all the notations, this is the formula VI cos phi. Okay, got it guys? So pause the video, copy down as neat as possible. We can do next problem. Okay friends, now we can solve second problem. Okay, this question asked in set 1 again of VTU model question paper. So let me read the question. When a three-phase balanced impedance are connected in star, so there is an impedance in each phases and all these impedance values are same. Balanced means the value of this impedance, this impedance, this impedance all are same. That is called balanced. If all are different means that is unbalanced. Okay, got it? All are connected in star across a three-phase 415 volt 50 hertz supply. Okay, this entire star connected system or star connected load is connected across three-phase 450 volt 50 hertz supply, and they are telling the line current drawn is 20 ampere. See, when this load is connected to supply, the load is receiving a current of 20 ampere. So that current is line current. So they are asking at a power factor of 0.4. So the power factor of this entire load is 0.4 power factor. What is this 0.4? Nothing but cos pi. Value itself 0.4. Determine the parameters of the impedance in each phase. Okay. See guys, this type of problems are very important. Okay. Either they can ask leading or lagging. Same question may come. Okay. Need not to surprise. Instead of lagging, they will put leading. So to solve this type of problems, you must remember this note. In a question, if they given lagging power factor means, then you have to find the parameters of the impedance in each phase means, whenever power factor is lagging, you have to find what is resistance per phase and what is inductance per phase. Okay. In the same question, if they given leading power factor means you have to find resistance per phase and capacitance per phase. Got it? Now they given lagging power factor. Our aim is to find resistance per phase and inductance per phase. Okay. Only for this type of problems you must remember this note. Okay. So let me calculate impedance per phase. See guys, impedance per phase formula is phase voltage by phase current. See, this is the first step. You are always finding impedance. In AC circuit, try to practice how to find impedance. If you calculate impedance correctly, almost you can do the problem. You can easily do the problem. You can finish the problem with confident results. Okay, if you don't know impedance calculation, you have to give up this type of problems on AC circuits. Okay, so don't do like that. Give a try. It's not much complicated. Very easy also. See, impedance. See, in three phase, we are always calculating per phase values. Okay, once we know the per phase values, we can find line parameters by knowing the relation between line and phase quantities of star as well as delta connected system. So that's why in three phase we are always calculating per phase values. So impedance per phase is VPH by IPH. Now VPH, I need phase voltage. Phase voltage is not given in the question. They given line voltage. Okay. In a star connection, what is the relation between line voltage and phase voltage? Line voltage is √3 times of phase voltage. Like that, from that relation, phase voltage can be written as line voltage by √3. What is the line voltage? 415 divided by √3. So 415 by root 3, how much you will get? 415 divided by root 3. So I am getting around 239.6. Okay. You also got same answer. Okay, 239.6 volt. That is phase voltage. Now, what is phase current in star connection? See, in star connection, line current and phase current both are equal. So that current value itself, whatever they given, 20 they given, so 20 itself the current. So now calculate, put these values in impedance and then find impedance per phase. That is, phase voltage is 239.6 divided by 20. So this gives, okay, what is the answer? Divided by 20, getting 11.98. So 11.98 ohms. This is the impedance per phase. Okay, you must calculate this one. See, we don't know whether this, whether the components resistance per phase, inductance per phase, maybe inside they may connected in series or they might connected in parallel. Anything can happen. Okay, that data is not given. Okay, if they given, that is a different method. So watch regular videos. I solved a different type of problems on these concepts. Okay, so now see, you must remember, okay, since we need to find resistance and inductance, you draw the impedance triangle of series RL circuit. Okay, so this is resistance per phase and this is inductive reactance per phase and this will be the impedance per phase. Now from this we can write the resistance per phase will be impedance per phase into cos pi. Okay, impedance per phase into cos pi. So what is the value of impedance? What is the value of impedance we got? 11.98 ohms. So red is not working properly. Okay, impedance is 11.98. What is power factor? 0.4. So into 0.4. So multiply that into 0.4. So getting around 4. How much you got? 4.792. Okay, correct. 4.792 ohms. So this is the resistance per phase. Now I need to calculate inductive reactance per phase. What is the formula for inductive reactance per phase? Impedance per phase into sin pi. See, when cos pi is 0.4, you can easily calculate what is its value if it is sin pi. So that can be find out like this. See, cos pi is 0.4. Now pi is equal to cos inverse 0.4. So we get pi value. Shift to cos inverse 0.4. So getting 66.42. 66.42 degree. This is the value of pi. Sine of this pi, you will get sin pi value directly. So I am not calculating that. So I am writing here directly. 11.98 into, what is the value of sine? Sorry, sine. What is the value of pi? 66.42. Okay, sine 66.42 degrees. So please do it in calculator. How much we get? Sorry, 11.98 into sine 66.42. So getting 10.979 ohms. 10.979 ohms. What is this? Inductive reactance. What I need to find? Inductance per phase. Okay, inductance per phase. After getting this value, we know the relation XL is equal to 2 pi FL. XL is equal to 2 pi FL. Now we got inductive reactance per phase. Then obviously this will be inductance per phase. See, from this we can write inductance per phase formula can be written from this equation. That is, XL from that L can be written as inductive reactance per phase divided by 2 pi F. Now, what is the value of XL? 10.979 divided by 2 pi into frequency. What is frequency? 50. In the exam, if the frequency data not given, you can assume Indian frequency. Our country frequency is 50 Hertz. Okay. If not, even you can assume it. Okay. 99% they will give. Now do it in calculator. What is the answer you get? 10.979 divided by 2 pi into 50. So I am getting around 0.034. Okay. So I am keeping that answer in millihenries. Okay, I am keeping that in millihenries. So in millihenry, this become 34 point something. Okay. So that is this much, 34.94 millihenry. See, this is the components per or the parameters of impedance in each phases. In each phase, it is having a resistance of 4.792 ohms and it is having an inductor of 34.94 millihenry. See, these components, okay, in this impedance, it may be connected like this. Resistor, inductor are in series, or it may connect like this. Inductor and resistors are connected in parallel. Anything can, whatever the connection, you need not to bother. Okay, if they are given connection, for that slightly different. Method of solving like this only, slightly different. Okay, you can watch regular videos. See, this type of problems are very important, 100%. Okay, please pause the video and then copy down as neat as possible. Okay friends, now we can solve question number 3. Okay, I am not sure about whether this question asked in set 1 or set 2. That's why I am writing it may be in set 1 or set 2. Okay, see, a balanced 3-phase star connected system draws a power from 440 volt supply. So in order to measure that power, they connected 2 wattmeters are connected. The wattmeters are indicating a power of, one wattmeter shows 5 kilowatt, other wattmeter shows 1.2 kilowatt. With this data, you have to determine power factor and what is current in the circuit. So this is the question. See, this type of problems can be solved by almost all types of students. Okay, average students, above average and toppers. All students can easily solve. Okay, nothing, no logic in this problem. Very simple, easy to solve. Previous problem, question number 2. If you understand the subject in a clear manner, then only you can solve question number 2 type. Okay, second question, what I solved now, previous problem. Okay, let me start this. See, total power means, we know that, okay, in a 3-phase 2 wattmeter method, if I add 2 wattmeter readings, you will get a power. 3-phase power is measured by using 2 wattmeter method. So what is the W1? 5 kilowatt and W2 is 1.2 kilowatt. 5 plus 1.2, 6.2 kilowatt. This is the answer for first question. See, simply addition. See, that's why please don't leave any topic. You prepare, you identify the easy part. Okay, and then you try to find this one. At least you will get 1 or 2 marks. Okay. So next is power factor. See, while calculating power factor, and some students have doubt, so how can you take W1 5 kilowatt and W2 1.2? They are not specified. W1 is that much, W2 is that much. They are not specified. How can you take? See, under such condition, okay, you have to take W1 reading highest wattmeter. Okay, which one is having highest reading? W1 is having. So 5 kilowatt is highest. That one you can consider as W1. Smaller reading consider as W2. Sometimes they will give W1, W2, WA, WB like that. Wattmeter A, wattmeter B, like that they can give. Now, to find power factor, use this formula. Very easy way to solve. One formula is there, power factor is equal to cos pi is equal to cos into tan inverse of root 3 W1 minus W2 divided by W1 plus W2. So that is cumbersome, complex. Okay, refer this type of method to solve the problem. Tan pi formula is root 3 W1 minus W2 divided by W1 plus W2. Very simple. Just write the values. What is W1? You write 5 and W2 is 1.2. See, I am writing direct value. Okay. Don't write here 5000. 5 kilowatt means 5000 and 1.2 kilowatt means 1200. You have to write both these values either in kilowatt or in watts. Okay. One in kilowatt, another one in watts. 5 minus 1200. Lot of difference in your answer. Finally, you will get 0 marks. Keep everything in watts only. Otherwise, all these readings in kilowatts only. Okay. Precaution. Very, very important. Don't do such silly mistakes. You are going to lose marks. So, calculate this. How much we get? Okay, do along with me. Root 3 into 5 minus 1.2 divided by 5 plus 1.2. So, getting positive value. Okay. So, I got tan pi value 1.061. See, whenever you got tan pi value positive means you can define the nature of the power factor will be lagging. The nature of the power factor is lagging. When tan pi is positive, lagging power factor. If I got tan pi value negative, then you can take the power factor of the circuit is leading. Okay. Now find pi value. What is pi value? Tan inverse of 1.061. So how much angle you will get? Calculate. Shift to tan inverse. Answer. Getting 46.7. Okay, correct. 46.71 degrees. What is this? This is angle. Okay, phase angle. Now calculate power factor. What is power factor formula? Cos pi. Cos. What is the value of pi? You got it? That value you substitute. 46.71 degree. So that gives the final answer. Okay. Cos answer gives power factor is how much? 0.685. Okay, power factor is 0.685. Lagging or leading? Because tan pi is positive, therefore you must write power factor is lagging. Got it, guys? Very, very important problem. Next, finally, what is current in the circuit? See, we know that in a three-phase circuit, the power formula is root 3 times of VL IL into cos pi. From this equation, you find current. Okay. So, we have line current equation is power divided by root 3 into VL into cos pi. See guys, what is the value of power we have? 6.2 kilowatt. What is the voltage we have? 440 volts. See, one is in kilo range, one is in without range. It is direct value, 440 volts without powers. Same answer. If I want to tell it in kilovolt means 0.440 kilovolt. In this equation, everything should be in kilo or everything should be without power. Okay. So keep that in mind. So now I am converting this 6.2 kilowatt into watts. Then the numerator power becomes what? 6200 you can write it. Otherwise 6.2 into 10 to the power of 3. Now that 6.2 kilowatt converted to watts by that 10 power 3 into root 3. What is the line voltage we have? 440 volts. 440 into what is the power factor? 0.685. 0.685. Please do it in calculator, you will get. See guys, this is in volts only, this is in watts only, correct ratings. If you keep it here 6.2 only, if you not return 10 power 3, then your answer is wrong. Because you change the powers. Okay. All the parameters, voltage, current, power, all these powers should be same. Either should be in normal reading or kilowatt or mega readings, mega ohms, like mega ampere current, kilo ampere current or kilovolt. Everything should be in kilo, means kilo only. Everything should be in watts without powers. So keep that in mind. So please calculate. So you will get around 11 point. So I don't know. Wait, I will solve it. 6.2 exponential 3. Because I done this problem in regular video lecture. Same problem asked in model question paper. So I remembered value. It may be 11 point. That's why I wrote 11. But I don't know exact. So yes, it is correct. 11.876 ampere. Okay. See, this is a current, line current. See, they asked determine current in the circuit. Okay, what type of connection? Star connection. We have two currents, line current and phase current. Okay. But what is the ratio between line and phase current in star? Both are same, no? So I can find line current or phase current. Both are same. Therefore, IL and also you write IPH. Both the currents are same because concept is star. Okay guys, pause the video and then copy it down. Please give like to our videos. We can do next problem. Okay, hello friends. Now we can solve question number 4. So this question is in set 2 paper. Okay, set 2 paper. So please give like if you like. If you already understand the first 3 problems what I done, please give like. So now we can solve this problem. See, question number 4 is given in the model paper. So from this, what we are going to understand means, there will be questions in such a way that the students are going to think and they are going to kill their time in the exam. Okay. So that is this type of question. So VTU is telling that we are going to ask such type of questions. Okay. See, this type of questions, if you understand the subject clearly, then only you can solve it. Okay. It is not a direct formula question. Okay. You have to think in depth which formula I need to select, how to start the problem. It will be quite time killing. Okay. So there will be such type of questions in exam, real time exam. That is the indication from the model paper. Okay guys, let's start. A voltage of 125 volt to 60 Hz is applied across a non-inductive resistor, means pure resistor, connected in series with a capacitor, connected in series with some capacitor, and for that circuit the current of 2.2 ampere is passing. The power loss, they given some data. The power loss in the resistor is 96.8 watt. They given power loss in the resistor only 96.8 watts, and that in the capacitor is negligible. We know that pure capacitor never consumes power, so they are telling indirectly negligible. Calculate the resistance and the capacitance. So this is the question they give. They are asking find resistance and capacitance. This is like indirect way of solving. Okay. What is it? Normal method students can try to solve the problem. They can move their pen. Voltage should be given, R should be given, capacitor should be given. Then they can find R, voltage across resistor, voltage across capacitor. Like that they are solving. But this is in a reverse way. Okay. We have to identify some logic what is there in this problem. Okay. So let me find impedance. Always start with impedance. Okay. Impedance formula is what for AC circuit? Z is equal to V by I. If it is 3 phase, you write ZPH is equal to VPH by IPH. That's it. Okay. Now, they given voltage and they given total current. They given RMS values of voltage and current. So, you take those values and calculate. What is the voltage? 125. What is the current? 2.2. So, from this, what I got impedance? So, 125 divided by 2.2. So, 56.818 ohms. So, this much is the impedance of the circuit. Now, they given resistor. In that resistor, this much power is consumed. You know what is current flowing in the resistor. By knowing current and power dissipation in the resistor, you can easily find value of resistance. Find resistance value now. See, power formula is I square R. Okay. Now from that, R can be written as powered by current square. What is the value of power in that resistor? 96.8. And what is the value of current? 2.2 square. Doing this, 96.8 divided by 2.2 square. How much you got, guys? Very good. 20 ohms. So we already done 50% of the problem. The value of resistance is how much? 20 ohms. Next is very important, capacitor. So how to find the value of capacitance? See, out of 125 volt, there will be a drop in the resistor is VR and drop in the capacitor is VC. So we know that voltage drop across resistor is I into R and voltage drop across capacitor is I into XC. Okay. Let me find voltage in the resistor. What is current flowing in the resistor? What is current flowing? 2.2. What is the value of resistor? 20. So 20 into 2.2. So getting 44 volts. Okay. 44 volts. See, even though while doing this in calculator, students will type like this. 22 into 2. 22 into 2. Otherwise, 22 into 20. Then they will get 400 something. They are going to miss this point while typing in the calculator. Whatever they got, they will write immediately. So don't do such silly mistakes. Okay. So we got voltage across capacitor. See, what is the total voltage? 125. Out of that 125, 44 is here. Remaining voltage will be here. But don't do direct mathematics. 125 minus this voltage will be available here voltage. Available voltage across capacitor. Not. It is AC circuit. In AC circuit, you have to do vector addition. In DC, you can do direct addition. Okay, got it? So, we can write the voltage across the circuit is equal to square root of VR square plus VC square. What is voltage connected to the circuit? 125 volt is equal to, what is voltage across resistor? 44 volts, that is 44 square. And I don't know what is voltage in the capacitor. Okay, you can solve this. Square on the both the sides. Otherwise, in this calculator, you can directly solve it. 125 is equal to square root of 44 square plus alpha x whole square. Shift to solve equals. Getting 117 volts. I got voltage across capacitor is 117 volts. So, what is the voltage across this capacitor? 117. Since it is series circuit, whatever the current flowing in the resistor, same current will flow through the capacitor. Now, by knowing current flowing in capacitor and voltage across capacitor, I can easily find capacitive reactance. So, from this, we can write capacitive reactance is equal to VC by I. Voltage across capacitor is 117. Current flowing through the capacitor is 2.2. Please tell that answer. 117 divided by 2.2. How much getting? 53.18. Very good. 53.18 ohms. So we got capacitive reactance 53.18. See, once I know the capacitance, I can easily find out capacitance value by knowing frequency. What is the formula for capacitive reactance? 1 by 2 pi Fc. So from this, capacitance formula will be 1 by 2 pi F into Xc. Simply, okay, interchange. Cross multiplication. Now, please do it in calculator. 1 upon 2 pi. What is the frequency? See, frequency 60. Don't take 50. Okay, you are going to lose marks. Don't do such silly mistakes. Okay, I know. I see many students. If they given data, they will take their own data. Okay, so don't do such mistakes. 60. What is the value of capacitive reactance? 53.18. What is the answer? What is the answer? 1 divided by 2 pi into 60 into 53.18. How much you got? How much? 4.98. So guys, in calculator we got 4.98 into 10 to the power of minus 5. What is the unit of capacitance? Farads. Don't keep it like this. You keep the answer in standard form. Okay, only farad or millifarad or microfarad or nanofarad or picofarad. Like that you keep your answers. It will be good looking. See, now I want to keep the same answer in microfarad. So put 9 this side. Then this become 49.87 microfarad. Micro is 10 power minus 6. So this is the value of resistance and capacitance for the given data. See, this type of problems are important. Means they are going to ask problems in such a way that students has to think how to solve the problem and how to start the problem. So it's going to kill the real time exam time. Okay, exam time will going to kill it by thinking. Your pen will not move. Finally, you are giving up the question. What is this? They are not given anything. How to find resistance, capacitance, like that. Okay, out of 100, around 70 students will keep on thinking. Okay, it depends on how properly you are preparing the exam. Okay, okay guys, pause the video, copy down. Okay friends, next is question number 5. This is the last problem asked in model question paper from both the sets. So totally from module 2 they asked 5 questions. In that 5 questions, 2 questions are quite difficult. Means they are giving indication there will be a difficult questions so that students will going to think in the exam. Okay, so it means unable to solve the problem. Like that questions may also come in exam. Like that is the indication given in the model question paper. And they given remaining 3 questions are easily solvable. Okay, if you know the formula you can easily solve it. So let see, this problem is very simple. But if you know calci operation properly, you will get answer. Otherwise, you get wrong answer. That's it. Otherwise, you cannot do also. So they are given 2 circuits. The impedance of which are given by, okay, in one circuit, the impedance of one circuit, first branch is 10 plus J15. This much impedance in one branch. In another branch, Z2 is 6 minus J8 are connected in parallel. The 2 circuits are connected in parallel. If the total current supplied is how much? 15 ampere. For that parallel branch, 15 ampere current is supplied. What is the power taken by each branch? Okay, what is power consumed in first branch? What is power consumed in second branch? Otherwise, what is power consumed in this impedance and power consumed in this impedance? Okay, so to calculate power, we have to use this formula. What is power formula? I square R. I want to find power in first impedance. So we know that this is resistance and inductance, like that. Inductance, imaginary component, will not consume power. Okay, inductor never consumes power, capacitor never consumes power. So in this impedance, power is consumed due to only resistance. See, this 10 ohm is resistance and this 15 ohm is inductive reactance. So it is in the form of R plus JXL and this is in the form of R minus JXC. Okay, power is consumed only in resistor. Okay, that's why we have to use this formula. P1 is equal to I1 square into R1. So now here I want to find current in first circuit or first branch. See, these two are connected in parallel. If I know the supply current, apply current division rule. Apply current division rule. Apply CDR and then find current in each branch. So current flowing in first branch is equal to supply current, that is total current, into, if you are finding current in this impedance, you take another impedance in the numerator, IT into Z2 divided by sum of the impedance, Z1 plus Z2. Only this you have to remember. Okay. Now enter all the values. They are given 15 ampere current. You write in polar form. 15 at an angle 0 degree into what is impedance value of Z2? 6 minus J8 divided by Z1 plus Z2. Enter the value. In calculator, default in calculator you will get an answer in rectangular form. like this you get 1.967 minus 8.36 J. You convert that into polar form. Then we get 8.58 at an angle of minus 76.75 degree. Now this value you have to take it as I1 value. Okay. So this is RMS value of current. So in polar form this magnitude indicates RMS value. That's why you have to take that current. So 8.58 I1 square, 8.58 square into resistance of first branch. What is the resistance in the first circuit? 10 ohms. So 8.58 square into 10 you get 736.164 watt. That is power consumed in one of the branch. Okay, that is what they asked. What is power taken by each branch? In one branch, that much power. Same concept. Power, find current in see power in second branch is I2 square into you take another branch resistance. This one I taken R1, this one I am going to take R2. That's it. I2 square into R2. So find I2 current. Now I2 is equal to, if I want to find current in this branch, supply current into other resistance divided by sum of the impedance, not resistance, impedance. So IT into Z1 divided by Z1 plus Z2. That's it. Take the calculator, enter all these values. In the new calculator, you can enter this as it is. Okay. You can enter mixture of one polar, one rectangular, or rectangular into polar, anything, any combination you can enter it. By putting proper brackets, your calculator will give solution. Okay. By solving that, we get 13.03 plus 8 plus 36J. This is the value of current in rectangular form. I2 current in rectangular form. You convert into polar form. Why means I need this value of current I2 that is available in polar form, because this I2 is RMS value. So by converting into polar we get 15.483 at an angle of 32.68 degree. So this much current. Now this value you should consider for I2. So power in the second branch is I2 square R2. I2 15.483 square into 6 ohm. Why taken 6 ohm? R2 value is 6 ohm. Okay. So power dissipated in power consumed in this branch is 1438.33 watts. See, very simple. Okay, you know how to apply current division rule. Rest, take the calculator, enter the values, and write the solution. Whatever the answer displayed in the calculator, that you can write it down. See, key point, if you want to score marks, numericals from module 2 means you must learn first how to use calculator and then how to find impedance for a given circuit. Okay, series RL circuit, series RC, series RLC, combination of that, how to write impedance, that is important. And then how to convert rectangular to polar, that one also you must know. Along with that, formulas. Okay, formulas for power. Power is equal to VI cos pi, reactive power VI sin pi, apparent power S into V, S is equal to V into I, power factor formula cos pi, R by Z, from impedance triangle, from voltage triangle VR by V, and from power triangle, power factor formula is P by S. See, you must know all these things. And coming to combination of series RL circuit, voltage across resistor is I into R, voltage across inductor is I into XL, and voltage across capacitor is I into XC. You must know all this. Okay, then only you can score full marks in module 2. See, module 2 only 2 weightage. First weightage is full of derivations. Okay, module 2. You should practice derivations. 100% you can score full marks from the derivation questions. Okay, definitely derivations will come around 10 to 15 marks from module 2, and they will ask problems based on the derivation itself. Okay, correct? So practice problems and practice derivations in a equal weightage. Okay, if you didn't get problems by solving so many number of hours, okay, if still you didn't get what is AC circuit, what I am doing, if you don't get this, then please leave, don't touch the problems in AC circuit. If the topic is troubling you lot means, okay, you try to overcome that. Okay, you find solution for yourself. If not possible means, don't study problems on AC circuit. But if you watch the video, see, I combined all the 5 videos in one content. Okay, it may be a lengthy. Each problem take 10 to 12 minutes. Okay, it may be lengthy, but if you watch correctly, 100% you can solve problems if they ask the same pattern of questions by changing the data. Because I am not doing the same problem in the video, I am explaining. If they ask in other way how to do, that is also explained. So please watch the video in a continuous stretch. Okay, guys. Please give like to our videos. Share this video content to all of your friends. Tell them to subscribe our channel. Okay. So meet you on next lecture, Module 3 numericals of model question papers. Till then, take care. Bye bye.